In southern Africa, there are special circumstances that govern seasonal patterns of rainfall. These involve local patterns of atmospheric and oceanic circulation. Our focus is on southern Africa and Mozambique, flanked by the South Atlantic Ocean on the west and the Indian Ocean to the east. The Tropic of Capricorn sits roughly here. Off the South African west coast, there exists a persistent high-pressure zone that originates at the confluence of the southern Hadley and Ferrel cells. Combined with the Earth's rotation, this produces an anti-clockwise rotation of winds known as the South Atlantic anticyclone. This is also known as the South Atlantic High. There's a similar zone of high pressure off southern Africa's east coast with similar anti-clockwise winds known as the Indian Ocean anticyclone. These two anticyclones bracket a persistent low-pressure system that sits over the subcontinent, known as the Angola Low. This zone of persistent low pressure is due to the increased heating of the ground surface by the sun, as well as the high levels of evapotranspiration there. Combined with the rotation of the Earth, this produces a clockwise circulation of winds opposite to that of the oceanic anticyclones. We'll come back to these patterns of atmospheric circulation momentarily. The same forces that cause air to circulate as winds causes waters in the ocean to circulate as well. These are more complicated patterns than for the winds. The first complication involves the topography of the South Atlantic Ocean floor. This is a large ridge known as the Walfish Ridge that extends 3,000 kilometers southwest from the continental shelf near the Kunene River mouth to the Mid-Atlantic Ridge. This divides the ocean floor into two basins, the Angola Basin to the north and the Cape Basin to the south. To the north of the Walfish Ridge, there is a large clockwise circulation cell of warm water known as the Angola Current, constrained to the east by the African coast and to the south by the Walfish Ridge. To the south and east, a strong current of warm water emerges from the Mozambique Channel and along the south coast of South Africa. Near Cape Agulhas, the prevailing west-to-east current in the Southern Ocean sweeps this flow of warm water back to the east to form the Agulhas Current. The retrograde flow of the Agulhas Current draws up cold waters from deep layers of the ocean, which is drawn up along southern Africa's west coast. This is the Benguela Current. Two forces mediate the flow of this current. Along the coast, the Benguela Current flows north to the Walfish Ridge until it flows parallel to the Angola Current. The Benguela Current is also drawn west by a large-scale circulatory flow of water between South America and Africa, known as the South Atlantic Current to the south, and as a southern-south equatorial current to the north. The southern-south equatorial current draws the Benguela Current to the west. The strong changes of direction at the confluence of the Agulhas and Benguela currents generates a periodic series of large eddies known as the Agulhas Rings. These play a major role in redistribution of heat from the Indian Ocean into the Atlantic. As we shall see, this redistribution of heat plays an important role in determining the climate of southern Africa. What all this has to do with rainfall is where the rain comes from. Between the Angola Low and the Indian Ocean anticyclone sits a persistent atmospheric feature known as the tropical temperate trough. This tends to draw warm and moist air in from the Indian Ocean, which generates considerable rainfall along with it. The precipitation of water vapor from the Indian Ocean on the east of the subcontinent means there is less to precipitate to the west, forming a sort of arid rain shadow to the west. The Namib climate rests upon a complex interaction between all these factors and how they have changed with time.